Cloud computing can become very expensive if you are not careful. Rapid scaling is a technique to use cloud computing very efficiently. In this video, we will demonstrate rapid scaling on AWS Marketplace. We will start from zero, we will initiate a head node and then run up to 10,000 jobs very efficiently. Hi, my name is Andrea Casotto. I am Chief Scientist at Altair Engineering. If you forget instances turned on or if you have large amounts of data, your cloud computing bill at the end of the month can be surprisingly large and you may be throwing your money down the drain. Let's use the power of cloud computing, but let's do so very smartly. The rules of rapid scaling are simple. Always show how much money we are spending. The cost at rest must be zero or practically near zero. The cost may go up with the workload and may go up rapidly, but it's also important that it will come down very rapidly as well. Finally, the cost must go up not based on the size of the workload, but on the speed at which the workload is moving. And this is an idea on which Altair has a patent pending. Rapid scaling comes in two flavors. You can either call Altair and we will help you set it up and give you a license, or you can do everything by yourself, go to AWS Marketplace, and you don't even have to call Altair. This is what the rest of the video is about. We make two assumptions. You already have an AWS account and you have already subscribed to Altair Accelerator, which is the umbrella product under which rapid scaling is offered. From now on, we will go through the process of starting the head node. In the AWS console, go to Marketplace Subscription and launch a new instance for Altair Accelerator. Select the latest image and select the region in which you want to launch the instance. This will be the head node. Now through the normal EC2 console, we are going to select an instance type. In this case, we select a T2X large, which is probably good enough for up to 1 million jobs. Couple of notes. You have to be careful about the IAM role, which must allow access to the AWS CLI. Luckily, most accounts already have that. Everything else can be left as default. Then select some space for local storage. 30 is fine, 8 is fine, depends on how many log files you want. Choose a nice name for your instance so you can recognize it in the list. And finally, configure the security groups for rapid scaling. You need to open a few ports. Make sure they are open, but only from your IP. So the ports are 8787, 6271, and 5555. Please remember to also lock down the SSH port. Finally, we can review and launch. Everything looks good. Let's create a key pair. In this case, we're going to use a new one and we're going to store it in a location. I will show you what we can do with that. So while we wait for the instance to launch, we're going to save the key into a location and make sure that it's only readable by us. So while the instance is launching, let's find some of its characteristics. In particular, the public name of the instance is important because we are going to use it to use SSH to connect to it. So let's copy that and now let's connect to the instance using SSH. We have to use the key pair that we've just created. The user is EC2 user, that's a characteristic of the Amazon Linux. And then we have to use the public name of the instance. So here we are finally on the head node. There is a welcome screen and there is a README that you want to read carefully, but really there isn't very much to know about it. There are just two things that you need to do. One is you need to launch Rapid Scaling and then change the password for a user called ncadmin. So we're going to follow the instructions in the README file. And so the first step is launch Rapid Scaling. This is a step that takes about overall 5 minutes, maybe more. Some of the longest part is the creation of the EFS filer. And we have to wait for the DNS to propagate correctly, the name of the filer. So this is a little bit accelerated. Luckily, we don't have to wait all that time. The EFS filer will be used as a shared filer, kind of like what you already have on premises. As soon as EFS is mounted, we start launching the Altair Accelerator subsystem. So we start with License Monitor, which will be used to monitor licenses if you have them in the future. Then we launch License Accelerator, which is actually the domain in which Rapid Scaling operates. Finally, we launch Network Computer, which is the actual scheduler. This is the system to which you will submit the jobs. Then we also download all the tables with the pricing for EBS, for EC2, for EFS. We want to have control on pricing. We want to have the latest list price. For spot instances, we will update the tables about every 30 minutes. And when all the systems are launched, let's change the password for the user ncadmin. Let's use a very strong password, please. Now we have the Rapid Scaling head node up and running. Let's now run some jobs. We start by changing the directory. We go to the share filer in the home directory for ncadmin. And we take a look at the machines connected to the farm. There is only localhost over there, which is the head node. There are 4 slots, they're all idle. And now we submit a test workload consisting of 10,000 sleep 5 jobs. These are very easy jobs to submit. They don't do anything, but we can submit 10,000 of them. Let's take a look at the summary of what the system is doing. Right now there are 9,992 jobs in the queue, and 4 are already running on the head node. The other 9,900 plus jobs are waiting in the queue. They're all waiting for Linux 64, which is the condition for Rapid Scaling to react, provide more hardware, so new instances. So you see at this point we already have 10 new instances called S1 through S10. They're all new on-demand instances of the type CX large, which is the type that is the smallest that can execute the jobs in the workload. The instances take some time, about a minute to boot. That's what we are waiting for. But at some point we're still running 4 jobs now. We're going to be running more jobs as the machines actually connect. So you see at this point we're running 10 jobs, and even more machines are being requested. Machines S4 and S5 are currently running 2 jobs each. And now we can connect and see the same information with the browser. All of our applications have a built-in browser interface. So here we are connecting with Safari, which has some special checks about connecting to an HTTPS site. So here we are connecting Here is the login input. We are going to connect as NC-admin with the password that we provided earlier. And this is the network computer interface, the one that shows the workload. This is the actual scheduler. Now we're connecting to the other port 8787, which is license allocator, which is where Rapid Scaling is actually running. That's where we are going to see the actual costs of our farm as it grows in response to the workload. This is the instance cost page. As you can see, we are now spending about $7 an hour for a total aggregate cost of $63,000 per year. We are not going to keep it up for a year. We're going to keep it up for just a few minutes. For each instance, we see what type of instance it is and how much it costs on an hourly basis. This interface also presents other types of costs, for example, the cost of the storage. And so here is the storage divided into EFS storage and EBS storage. We also have a graphical representation of the cost of the farm. In the top you see the cost, and in the bottom you see the workload. The workload shows that we had at some point 10,000 jobs in the queue, and that the queue started being processed. In the top line instead you see two curves. The blue line is the total cost of all AWS instances, including the head node. The green line only shows the cost of the compute instances. Now watch carefully. At some point we have 6,000 jobs in the queue, yet Rapid Scaling stops requesting more instances. That's because the slope of the workload is sufficiently steep. We know we're going to terminate quickly. When the workload completely terminates, the instances are also terminated to reduce the cost of our Rapid Scaling farm. After submitting and executing the same workload a couple of times, we can see here the essence of how Rapid Scaling works. The cost grows with the demand and it immediately shrinks as soon as the workload is completed.